All right, Bernhard. Final recording of the year. I'm really, really thrilled. Back to the town where it has all started for me, career-wise. So Lübeck in Germany, or close to Lübeck in Stockelsdorf.
Welcome home,
Yeah,
Simon.
man.
Welcome home.
So really excited to be here at
Perfect.
VC Battery and talk about X-rays for battery inspection and what competence you have to deliver. But before we come to today's topic, Bernhard, let's talk about your path into the field of batteries.
Yeah, I had a very good adventure ride the last 6 years in the battery field. So my background is 26, 27 years in the X-ray world.
Mm-hmm.
So I was doing a lot of business startups, building up China, building up electronics market segments. And then I started to get in touch with the battery market 6 years ago. And when you saw the numbers at that time, they were amazing. 20, 30% growth rates for the next 10 years. This was factor X better than even in the semicon market. So my heart went to the battery. So, and then I looked around. I was at a previous X-ray company in the management team. And then I said, well, but who's going to go this path with me? And then I looked around into the X-ray market and I found, not far away from my home area in Hamburg, I found in Lübeck, VC Consult.
Yeah.
And VC Consult is a family-owned business, 26, 27 years, also in X-ray, same like me, second generation, family-owned business. And I talked to the shareholders, to the CEO, Bernhard Schulenburg, and we thought, wow, that's a perfect idea. Let's do something together into the battery world.
Mm-hmm.
And that's why I'm here with you today.
Yeah, got it. So what are you doing? What
So,
is the key innovation of VC Batteries and VC Consult in that regard?
yeah. So why did I come to VC Consult? So VC Consult, from the history, maybe to start with that. VC Consult is started as a software company.
Mm-hmm.
They started they were the first guys having fully automatic analysis of 2D X-ray images. That's how they started. And after a certain period of time, their customers asked, can we have a turnkey solution from you? Not only X-ray software analyzing. So they started to build an engineering division up for supplying turnkey solutions to the customers.
So starting off as a software company,
Yes,
and then opting into engineering, right?
exactly.
Yeah.
And then not even that was the limit, because then, when you're going closer to production, then the people start to ask you, can you make an automatic loading, unloading? Can you automate? So from an offline system provider, we went to an inline system provider having a lot of automation. So now we have 3 columns as a company. Software, engineering means customization. So we are the world market leader in customized solutions in X-ray.
And we saw a couple of examples that we
really,
can also picture here during the tour
yeah,
that you gave me.
exactly. Right? The physics are the limits. Everything else we can do, all the manipulation, all the material handling, and on top we can have the automation. And so these 3 columns, that was driving VC Consult over the last 25 years to grow. Last 5 years, they grow 20% per year, every year. Even last year, we just hired 60 people in 1 year, 25.
Okay.
So we are growing tremendously. And with this competence I saw in that company, that's where I've joined this company.
Talking competence and the reason why you're growing, I mean, your customers, the market, has to see something in the product, the services you deliver. What is it that lets you grow? What is the key competence there? Really, the selling point where you can convince the customer.
I think the number one is there is no problem we cannot solve for the customer. So if it's solvable by the physics of X-ray, we can penetrate it, we can see the defects the customer wants to see.
Yeah.
Then we're going after that. And we can, as in the tour we have done, you can see all these different kind of systems. We start from standards. We try always to be on the standard side, first of all, because price performance is in certain industries very important, especially in automotive. Yeah. But then when there's something special, we are willing to innovate with the customer. So that's very important to understand. We are willing to innovate for the customer, with the customer, and creating maybe the next standard. In the beginning, it's a first customized system, but then in the next step, it's a fully new standard product with full of innovation.
Yeah, as you call yourself the world leader in customized X-ray solutions, right? It's hard to talk about product portfolio if you say like you do customization, but I think nevertheless you kind of pinpointed like the 3 areas you're acting in. And in the tour, I also saw that you have a standard modular
Exactly.
solution that you build up on and that you then customize. So can you explain this a little bit to
Yeah.
go through the different systems and machines that you provide?
Yeah. So all of the machines is one thing in common. It's a software platform.
Mm-hmm.
So we really want to make sure that all of our machines, whether it's a single made machine or it's a one at times machine, it's always running on the same infrastructure architecture of the software platform. So this gives us the flexibility towards the customer to find the best suitable solution. And on top of that, we are building layers of extra solutions, either extra manipulation, either extra software analyzing solutions. So, but we always have the same fundament, and
Yeah.
we are building up from
Mm-hmm.
the bottom. That's how we are very successful
Okay.
in the market right now.
Okay. And then that's the software, but on the mechanics side,
Mhm.
when we talk about the inspection, what are the differences there? Because we saw some traversing mechanisms,
Mhm.
but we also saw some robots that were
Mhm.
also turning
Mhm.
it.
Mhm.
While I remember when I was heading eLab and built up the pilot line there,
Mhm.
we were talking also to Fanuc and those
Mhm.
robot manufacturers about the accuracy, the position
Mhm.
accuracy, right? Because we also are thinking like, hey, we can just position it with
Mhm.
a robot arm at the station where we need it, like for example the tap welding, right?
Yes.
Just position it there, weld it, and then hover over to the next one
Yes.
and seal. In this
Yes.
case, was pouch cell production. But the accuracy was kind of at 200,
Mhm.
150 micron.
Mhm.
And I think the industry has matured there as well,
Absolutely.
which allows you also to include different automation systems.
Absolutely.
So maybe you can explain that a little
Yeah.
bit.
So what you have seen in the tour is, for example, we have in the last couple of years innovated on robotic trajectories,
Mm.
utilizing a robot not only as a pick and place
Mm.
device. That's what everyone knows
Mm.
in the automation. You
But
grab
as a
position,
positioning device.
you put something into a machine, and then another machine is doing something with it.
Yeah.
So we further developed the robot not only to have a pick and place, but also to use it for manipulation in an X-ray beam
Mm-hmm.
very accurately. And this is then the big difference from a 200 micron accuracy going down to 20, 30, 40 micron position accuracy. This is now the situation. Now we have this kind of accuracy,
Mm-hmm.
and with that we can really achieve the next level of manipulation concept, reducing cycle time, because you don't have to put it somewhere and then take another device for
Yeah.
manipulating. You keep it in the robot, so the part changing time is much more reduced, and we're utilizing the current accuracy of robotics.
Mm-hmm.
Very important for us.
Interesting. Yeah. So what if a customer really wants to go big? I mean, this is not batteries yet. We'll
Mhm.
come to that
Mhm.
in a second. But I
Mhm.
was impressed. You were talking about bunkers.
Mhm.
So what is that about?
Yeah. So one of our big industries we are very successful is the aerospace market
Mm-hmm.
segment. And in the aerospace market segment, if you talk about planes, they are big.
Mm.
Wing sections of a plane are very big. And they are also very safety critical.
Yeah.
So they also need to be inspected.
Mm-hmm.
And as long we can penetrate a wing with X-ray, we can analyze it. We can check the image quality. What is the biggest challenge then for a lot of other providers is to build a system around a big wing. And
Mm-hmm.
this is what you have seen. We have scalable systems. You can build up from 3 to 10 meter height, or you can go into the room from 3 meter to 10 meter width. It doesn't matter for us. We can scale the size of every imaginable part.
Mm-hmm.
We can also then have special developed parts holders, manipulation system of parts. And then we put this all together in one big machine. And what is then, of course, you also need to have the engineering capability to make sure that the X-ray protection is safe.
Mm-hmm.
So we are also making the construction of huge bunkers, 10 meter wide, 5 meters high. And on top of
1
that,
meter wall thickness you mentioned, right?
yeah, that's the crazy stuff, also in terms of X-ray sources we are utilizing.
Yes.
We are starting from the very small X-ray sources, 120, 160 kV ranges. People in X-ray knows that is you can
Kilovolt.
kilovolts
Mm-hmm.
ranges, and then we go to standardized 450 kilovolt ranges. And with that, for the people, it's about 60, 65 millimeter of steel you can penetrate. But then we don't stop. We also use other sources, so-called linear sources, which can go up to 9 MeV, 9,000 kilovolts,
Mm-hmm.
which is a factor 20 even more than the standard X-ray sources. And with that, you can penetrate up to 300 millimeter of steel.
Mm-hmm.
So, and this is
That's
then
30 centimeters, pure steel.
yes, and
Okay,
um and this is then really crazy. And for that, these bunkers then need to be 1 meter thick. These are concrete bunkers. And then, of course, you have big doors, lead doors to get the samples in, get the samples out.
yeah,
We're working there with partners together in the various countries, in US or in Asia or in Europe. So we don't need to transport concrete from Germany to United States, but we
sure.
have all the know-how to do that.
Gotcha. Okay. And now let's segue over to the main topic. I
Mm-hmm.
mean, this vehicle was built, and this whole expedition is about batteries,
Mm-hmm.
right?
Mm-hmm.
And how we can make batteries successful in
Mm-hmm.
Europe, ideally coming from Europe
Mm-hmm.
and bringing all the competences together.
Mm-hmm.
So let's talk about your competences in battery analysis inline. I
Yeah.
think you have something to answer there.
Yes. Yes. So coming to the speed, what is needed really in the battery production world. When you go back to what is the situation today, when you talk to German cell makers, European cell makers, Asian cell makers, all of them, they're using offline lab equipment for 3D dimensional measurements with X-ray of battery cells, because they all know it's very important data
Mm-hmm.
to improve the quality of my cell production. And they are misusing offline equipment for this data analysis. So a cylindrical cell, they need maybe 10, 15, 20 minutes for scanning and analyzing on top. Uh, a prismatic cell, they need 2 hours and plus analyzing on top.
Mm-hmm.
So it's a huge problem for the cell makers today to come up to speed. Because what they really need is they need some instant result on the production
Immediate
floor,
insights.
immediate insights
Yeah.
for fast insights, fast corrections.
Mm-hmm.
And that's where my adventure started with VC Consult, because we had identified complete new image X-rays, complete new X-ray sources.
Okay.
X-ray sources which came from a semiconductor environment, being very established as inline products, but never used in the imaging domain like we wanted to use it. And the big difference of this X-ray source technology is that the photon output is a factor of 30 more than conventional X-rays. Factor of 30 more. And
Okay.
that is mind-blowing.
It's
But
like 1 second versus 30 seconds.
exactly. So in the car, when you talk about a car, you have a car, you buy a car, it can go 100 kilometers per hour. And now you have 30 times more. Yeah, you can go 3,000 kilometers per hour.
Mm.
This is just to
Yeah, it's
understand the
also a
dimension,
good
100
analogy.
to 3,000 kilometers per hour. But that is only the first part of the story. Where you have we found a very good X-ray technology, X-ray source technology, but we also had to find a very good image capturing detector technology also, because conventional detectors, they have frame
Yeah,
rates.
maybe at this point you can explain, because not everyone knows how an
Yeah,
X-ray
yeah, very good.
device works. Just explain conceptually, like, what do we need there,
Mhm.
and why does it matter?
Yes. So everyone goes to a doctor sometime and
Mm-hmm.
takes an X-ray image. So when you go to the doctor, you have an X-ray tube which is emitting X-rays, photons, and on the other side, when you're lucky, you have a digital detector to capture the image, or before in the old days you had a film to capture the
Mm-hmm.
X-ray. So yeah, and then you got a 2D image of your broken bone maybe, or
Mm-hmm.
whatever you wanted to see in your body. So this medical X-ray, we are using the same in the industrial. We have an X-ray source and a detector on the other side.
Yeah, but just higher energy and
Just higher energy and continuous. So when you, as a person, you cannot be in the X-ray beam for more than a few milliseconds, then you will be hurt. So in industry, the X-ray is permanently on, and it's penetrating any test sample you want to inspect for the quality.
Mm-hmm.
Now this is the basic. And the second basic is same like in medical. When the doctor is looking for some issues you have, maybe on the 2D image, he can't see good enough what is your problem.
Yes.
So then you know also that these very famous CT scanners you will put into a tube, and the detector is rotating around you and generating a 3D image from your brain, your upper area, or whatever problem you have. So there's a 3D image generated. And the same technology we apply in the industrial world. The only difference is that we are mostly we are not rotating the detector around the body. We are rotating the body or the test sample 360-degree
Yeah.
and leave remain detector and tube stable.
Yeah, in the case of batteries, right?
In,
We also had seen examples where you move the detector around
yes,
the object when the object is bigger.
especially
But
in battery, for what the technology we use, we have to leave detector and tube
and then
stable
turn the battery.
and turn the battery very fast.
Gotcha.
Yeah.
Mhm.
So in this image chain now, when we are at this 3,000 or even 5,000 kilometers per hour speed,
Mhm.
then which translate in the battery world, it translates into a scan time of 12.8 or 5 to 4 seconds for a 4680 cylindrical cell, as an
Versus a couple
example.
of minutes.
Yes, whereas a lot of minutes normally.
Yeah.
And this is just our adventure starting point, because then, do you know what's the file size of one cylindrical cell scan?
Yeah, I mean, well, you told me during the tour, right? And I was I asked you how many gigabytes, and I was
Yes,
thinking like, yeah, but maybe one or
exactly.
two,
So,
right? Because I know like how much imaging there,
exactly.
processing there is involved.
Yeah.
But that it is 25, I didn't
Yeah,
expect.
so 25 gigabyte for a
For one
full,
cylindrical cell.
for one 4680 cell in a 25 micron resolution.
Mhm.
There's a lot of data.
Yeah.
And we can scan, then in that speed, we can do this then up to 16 cells per minute if you optimize all the material handling, everything. This is a massive amount of data.
And if you want to do that in that frequency, I mean, the processing power, the data processing, the GPUs also
Yeah.
must be quite capable.
Yeah, so
I guess.
we had to learn to be a master of data transfer because of
Yeah.
the massive amount of data. So data transfer. Then once you have captured the data, you need to, in the 3D world, you need to reconstruct it into a 3D volume.
Mhm.
So the reconstruction normally takes also minutes and hours
Mhm.
for this amount of data. So we reduced the reconstruction time. That was one of our biggest innovation steps. We reduced the reconstruction time from several 30, 20, 50 minutes down to below 8 seconds.
Yeah.
Below 8 seconds for one cylindrical cell. And then on top, of course, once you have the image, it's not enough to have the image. You need to analyze it.
You need the knowledge about the image.
Yeah.
Yeah.
So, and there we use software technologies to analyze all the features which the battery makers wants to know.
Mhm.
Metrology, measurement data. That's the key essence of the data
like
we have.
anode overhang and yeah, you showed me that, right?
Yeah.
That where you kind of build the maximum, the minimum, the mean,
Yes.
and for every cell, so that the production engineers can immediately kind of, I mean, with 7 seconds delay, understand like what is going on, and then if there is a drift, for example, in the data, you see like, okay, there's some process flaw,
Yeah.
and then you can act, rather acting a couple of hours later and have produced 100,000 K of scrap, right?
So that's the biggest use. So we have two main use cases. The
Mhm.
biggest use case on the production floor level is to have fast insights and the chance to have fast corrections.
Mhm.
So this is everything about yield rate improvement.
Yeah.
It's the big essence, the big essence. There are other advantages even then below that on a process engineering level. A process engineer, they have a lot of iterations about new process steps. When you have a new process, you have new parameters in the manufacturing. You change chemistry, you change some mechanical items on the design of the cell. Normally, you're in this process change, you change first something on your production floor, then you validate if this change is right, and then you bring it back on your process floor.
Yeah.
And each iteration costs a lot of money. And you do this
And
time. You do it every time. You do it 5, 20, 30 times a year. Each process change costs you easily 500,000 euro each. And if with inline CT you can make this process change instantly around in the production line, you don't need to stop. You can keep the new products,
Yeah.
provided it's good what you have done,
Gotcha.
and run through. So it's another essence on the process floor. The second big thing is when we talk to process engineers, everyone tends to make by CPK design a lot of safety tolerance. You say to yourself, well, for example, take the very famous anode overhang. When you set the tolerance, let's say of 200 microns or 300 microns you want to have on your tolerance level. You put a safety margin on that the anode has still a higher distance to the cathode, just to make sure it's very safe.
Yeah.
However, you know by the design, you don't need it actually, but you're not safe that your production process is so stable.
The tolerances
Everything
don't
everything
allow
is
you to
rotating.
optimize to the
So when you have a constant
minimum.
measurement of
Hmm.
this, you can reduce the actual height of the anode to
Yeah.
the cathode. And this is you are saving material at the end. You're saving cost. And this is just one example of a lot of
Yeah,
process
but
data you can
critical
optimize.
question there. If I generate 25 gigabytes of data for
Mhm.
21700 cell, like what is the price point of storing and also making that data available later?
Yeah, that's a very good point.
What does data compression mean there?
Yeah.
Or is that also a
For us, this is the next question. So typically when our customers are with us and they see our machine, first of all, they understand all the use cases and they buy in ultimately. Yield improvement, CPK,
yeah.
process control, everything, they buy in. And then they start to think, wow, now I have my data. What shall I do with the data?
Exploding, yeah.
Because what I didn't tell before is there's another use case because you also have the life cycle use case of this data. So take
Yeah, but there's a difference, right? You have the data that you need right on site
exactly.
to optimize the production.
Yes, this you do right away.
Yeah, and
You can even decide you throw away the data because you made your correction.
yeah,
Or you can have a very smart.
like 2D image that is sufficient potentially.
You can
Or
decide whatever you like to store. There are a lot of details by individual customers where they have their own strategies. This is a little
Okay.
bit difficult to make this public. So everyone
Yeah.
is thinking in a very smart way how to retrieve my data in the best possible way.
Or the knowledge from the data.
The knowledge from the
Yeah,
data in
yeah.
the best possible way, and we help them how to
Streamline the process.
streamline the process, but also to store as much data as possible. So with our partners, we also
Or would you say store as much information as possible, but as little data? I mean, in terms of gigabyte as possible.
exactly.
Yeah.
However, there's still there's not black and white. There
Okay.
is we still believe that you should store a lot of data because when you throw too much data away, you can't understand so much later in the life cycle about your cell.
Okay.
What might have been wrong when you make a back check for a field return. So and therefore we put a lot of efforts into compromise to make the data reduction,
And compressing the data.
compressing the data factor 10 or 15 or even more in the future, that to make sure that you have the most important information. You're not losing information, but it's data compressed. And in terms of a use case calculation, the data storage in a cloud or something is still affordable in comparison to the return you gain.
Gotcha.
So
Yeah.
it's a real business case calculation about storage data cost versus what is my gain for the lifecycle data management. And I had, for example, I personally had 2 car recalls in my car history with electric cars.
Okay.
And a car being 10 days away from you at home and having a lot of people working on my car at the time, I know there are numbers, and we calculate this about 8 to 15,000 euro cost per one car recall. One car recall.
Yeah, the business case is done for the
If you could
manufacturer.
recall 30,000 cars,
Yeah.
it's crazy cost. If you only recall 3,000 cars because you have the life cycle data.
Because you know exactly this batch of cars, we had
Exactly.
this and this batch of cells, so they were okay, but those weren't, so only these. Gotcha.
It's mind blowing for everyone who is sitting there on the chair of the board
Yeah.
of this car maker to
Yeah.
say I need this kind of solution. Very important.
Yeah, that's interesting. And looking at all this potential, and also what I've seen on the expedition, talking to so many entrepreneurs, leaders of our field, from industry, from research, but also more and more from politics and investors. From your perspective, having also talked to so many, and we talked about this also off mic, right? Battery manufacturers and other component suppliers. What do you see Europe holding back? If you would give a bullet point.
Yeah. So I think we have to acknowledge or accept that the Asians, especially the Chinese cell makers, are 10, 15 years ahead in production know-how. They know how to run their production machines. They have all the process floor level know-how. They have this very wise operators who can fine-tune the machine, make sure that they're producing in a good quantity cells and they can ship good cells to the customers. However, we know that the yield rates they have are not good. They're definitely not good. Their production
That's why
capacities
they're talking to you, right?
their production capacities are much higher than what is really coming out of
Yeah.
for good sales. So, however, their business case, maybe also with some government money, is working, and that's why they're very price performance driven in the
Yeah.
market now and very attractive to car OEMs that they buy their cells. On a European level, this process know-how you don't have right now. So we are thinking about how we can bring them up to speed to have more process know-how, how to be faster in gaining this know-how on the process. And it's just about getting more sensors into the production floor and utilizing this data. So there are a lot of German sensor makers, also on the optical side, on the camera side,
I agree.
who can bring in a lot of know-how. And we are just another sensor. CT technology is another sensor providing a lot of rich data. We have partners, former Tesla people, who tell us 50% of the relevant data on the production floor needs to be 3D metrology data to optimize your process. 50% of that data is needed. And this was simply not available. And now we, with our disruptive approach of our technology, can provide this data on the floor level. And this is really mind-blowing to a lot of cell makers right now. And they start to understand. So the European and also US cell makers, they have to react maybe faster than the Asian players to adopt this technology and bring this level up to speed in their production floor. Because at the end, a car OEM only wants to have a good cell, a high performance cell, and a price attractive cell. And when you increase your yield rate, when you give better quality of your cells, then you have maybe a case where you can be successful in the market.
Then let's talk about the potential. I mean, there's the challenge that we have to learn, that we have to build up, to gather the data, to build the correlation analysis, to understand, like, when I tweak this parameter, this happens on the other side. But what gives us hope to invest in Europe and bring this industry alive here as well? What is the potential that we're building upon?
I believe in innovation. I believe in innovation. We need companies who are taking the risk for innovation. Companies who understand their domain, maybe on the optical side, maybe on fast processing of cathode anodes, having the knowledge of high-speed processing of anodes, cathodes in whatever way, assembly. So there's a lot of engineering capability in Europe, and I think, however, we have to drive the limits ahead of what is known in Asia and put this knowledge and know-how together in turnkey solutions in the cell manufacturing. But the key is innovation, number one. Second is the willing to have a risk-taking attitude for investment. You will not sell in 1 year or 2 years or 3 years. You have to have a long breath. You have to stand your way and look for partners, of course. Partners in the same domain, partners across your domain and the automation side. So we work a lot with automation partners who help us to get the cells to us and get them away. Also,
I think
Europeans.
I visited one, right?
Yes, you have. And then we need the cell makers, the Europeans, to work with us together to develop the right solutions. That's really the essence.
And I agree to those points. I see that there is potential, but I think and that is the second hypothesis of this campaign, to level up our game on that. So to connect more on an operative level. So final question. We are very close to Christmas now.
Yes.
If you would have one advice to all stakeholders out there, how we get ahead, what would it be?
Stay on course. Get through with your innovation in the one you believe in, because you only know your domain knowledge. When you are strong on that, when you believe on that, push it through and take the orders.
All right, so we put that under the Christmas tree. Bernhard, thank you very much.
Thank you
for that, and let's keep pushing.
Thank you very much.